Okay, so here's our next lesson on factoring. Now, some of this we already covered in block 3 if you were there, but otherwise we're going to look at a couple new types of factoring. Factoring is similar to dividing. There's a couple types of factoring we're going to look at here. We're going to look at factoring out a common monomial with a GCF. That's what we've already done. We're going to learn how to factor a trinomial, and we're going to learn how to factor one type of special case when that's called the difference of squares. And the last one, factoring completely, would be any combination of the three of those. So we'll take a look at what each of these means and a couple of example problems. First is factoring out a common monomial or the GCF. I'm not going to go through or read you the steps in the strategy. I'm just going to act them out in the problem. So first step is to do a prime factorization for each of these. So for the 12, it would be 4, 3, 2, and 2. x5 is 5x's. The 8 would be 2 and 4, and the 4 would be 2 and 2. And the x3 would be 3x's. And last, the 16 would be 8 and 2. And then the 8 would be 2 and 4, and the 4 would be 2 and 2. And the x squared would be xx. Now, when I look at this, okay, just like unit 0, and I'm trying to find the GCF, I'm looking for things that all three of these have in common. Okay, so if I go through, I have a 2, a 2, and a 2. So I'm going to write that out in front. Looking again, I have another 2, another 2, and another 2. So I'm going to put that one out in front as well. Okay, 3, not all these have a 3. So I'm done with numbers. There's no more numbers they all have in common. If I look, they all have x's. Well, how many do all of them have? It looks like 2 is the most. So I'm going to write, I could write 2 x's out here if I wanted to, or I could just write it as an x squared. After I figure out what the GCF is, I write down all the leftovers. So I have a 3 that's left over. And again, that's why I'm circling these, okay, because that makes finding your leftovers a little easier. So I have a 3x to the third. I have a 2x. And I have, what, a 2 and a 2. That makes 4. And there's no x's there, so plus 4. Okay, now, for argument's sake here, I need to make sure that I rewrite this here, or simplify this into 4x squared out in front. And I'm finished. So this is a 4x squared. Okay, so that's factoring out a common monomial or a GCF. The GCF would be what they have in common. Okay, this is the common. It's the GCF. These are the leftovers. Starts with doing a prime factorization. Now, the bad part here is the next type of factoring is completely different than that one. Okay, when you have a trinomial, all right, a trinomial is called a trinomial because it has 3 terms. And none of them have something in common. So if I did a prime factorization here, I would notice that there's not one thing that they all 3 have in common, mainly because I have the odd number with 2 even numbers, so I know that they can't be divided, and then all 3 of them don't have an x. So when that happens, I'm going to use this strategy here. Now there's like a lot of steps. It is specific, but if you follow the steps, it works every time. That's the great thing about it. Okay, so I'm going to carry out these steps. Step 1 is to draw a generic rectangle and a diamond. If you can't draw the diamond, just draw the x. Step 2 is to fill in the x squared term, the bottom left, and the constant term, which is the plain number, in the top right. Okay, usually I use shapes here to help you with this. Okay, so this goes in the box, this goes in the box. All right, the next step is to put the x term in the bottom of the diamond. Okay, so that's how your trinomial gets split up. I've used all the pieces. So what do I do next? I multiply the diagonal to get the top of the diamond, and that gives me negative 24x squared. I complete the diamond problem. So remember, to do a diamond problem, I'm asking myself, okay, what do I have to multiply for negative 24x squared? So that when I add, I get 5x. All right, the answer there would be positive 8 and negative 3. This is where some students struggle to come up with that. Just guess and check. Use your calculator, whatever you have to do to determine negative 24 for multiplying and positive 5 for adding. All right, so I fill those pieces into the box, and then I complete the generic rectangle, which we've done in other chapters. Okay, now when I do this, I got to have some strategy here because I want the 2x to be on this side because I know I get an even number with the 8x here. Okay, and then this would just be an x, so 2x and x is 2x squared. The x is going to need a negative 3 here. and the 2x is going to need a 4 here. I write my area as a product, and I'm done. So I have 2x cubed, or excuse me, 2x minus 3, and x plus 4. So you see why we did this in Unit 3 with areas of product, areas of sum, and all those types of things, because here we are in Unit 7 using this again to factor. So this would be your answer. This would be the factored form, the undistributed form. And we have one more type of factoring that we're going to talk about today, and that is factoring the difference of squares. All right, so anytime you are difference of squares, again, you're looking at this, you're saying, okay, the 9 and the 64 have nothing in common. They do not have letters in common. It's not a trinomial. That means it's special. It's a special case. It's a difference of squares for a couple of reasons. One, it's a minus sign. That's where the word difference, okay, comes in, minus. Squares means you can write everything as a square. So what do I mean by that? 9 can be written as a square. What is 9 as a square? It's 3 squared. The x squared already is written as a square. 64 can be written as a square. It's 8 squared. So that's the first step, write everything as a square. The second step is to take all of those and split them up. You have 2 of everything. So we have 2 sets of parentheses. You put 1 of each in each set of parentheses. So 1, 3 here, 1, 3 here, because there's 3 squared. There's 2 of them. 1x here and an x here, an 8 here, and an 8 here. The only way to multiply and get a negative is if you have a positive and a negative. Okay, again, it's specific. Okay, so if these didn't make sense to you, I would go back, rewind, rewatch, all right, and the process is very distinct, very specific. You should copy these examples down. You should copy the strategies and the steps down for each of them, all right, so that way when you're doing the problems on your own, you have a model to follow. And we'll see you in class.